Welcome to the deep dive. Whether you are prepping for a meeting, commuting, or just, insanely curious about the world, you are in the right place.
Yeah, we have a really fascinating one today.
We really do. So today we are taking a stack of really profound source material and unpacking an idea that, well, it might just shift how you see your entire existence on this planet.
Which I know sounds like a massive promise, but the concepts here are just wild.
Right. So to get into the right headspace for this, I want you to just imagine the Earth as this massive ancient archivist, like just this silent librarian methodically writing down literally everything that ever happens on the planet.
Obviously, it's not using paper and ink.
Yeah, no paper. It is logging the shifting continents, the ice ages, and, the occasional catastrophic asteroid impacts all in layers of mud, ice, and stone.
It's just a completely impartial record keeper. I mean, the planet simply absorbed whatever happens on the surface and permanently presses it into the rock layers for the rest of time.
Right. And for billions of years, that process was driven entirely by blind natural forces. But the source material for our deep dive today, it forces us to confront this staggering concept.
Yeah, the idea that we are no longer just living on the Earth.
Exactly. The argument on the table is that human beings have become a geological force so overwhelmingly powerful that, well, we are changing the planet on a scale that will be perfectly legible in the rocks millions of years from now.
We are essentially the ones writing in the Earth a diary now. And this brings us to the core concept of our exploration today, which is the Anthropocene.
The Anthropocene.
Yeah, it's a term you might have heard, like bleeding out of academic geology and into just everyday conversation. So anthropo, meaning human, and scene, referring to a geological epoch.
It's just such a heavy, provocative idea. So our mission today is to take an unhurried, jargon-free look at what it actually means.
Absolutely.
We're going to break down how time actually works for a planet, what specific evidence we are currently, burying in the dirt for future geologists to find, and perhaps most surprisingly, the fascinating scientific drama over whether this new era is actually officially real.
Let's start with the foundational piece here, because to understand how humans are supposedly hijacking the geological record, we really first have to understand how the Earth actually keeps time.
Right, which is totally different from human history.
Oh, completely. We have to step out of the realm of human history and into what geologists call deep time. I mean, the Earth is about 4.5 billion years old.
Which is just a number our brains simply aren't wired to comprehend.
No, not at all. It's too big.
I was reading about this in the sources, and the way geologists manage this immense span of time is through, this nested hierarchy of named time intervals.
Yeah, it helps break it down into manageable chunks.
Right, so you start with the largest chunks called eons, and those are broken down into eras, which are broken into periods, which finally break down into epochs. Think of it like the folders on your computer or just a basic calendar.
That's a great way to put it.
Yeah, so years contain months, months contain weeks, weeks contain days. It's all nested.
And to visualize how they actually read this calendar, you have to think about stratigraphy, which is the study of rock layers.
Okay.
So when a geologist looks at a canyon wall or, say, a deep core sample taken from the ocean floor, they are essentially looking at the spine of a massive book. Over millions of years, dirt, sand, organic matter, it all settles at the bottom of lakes and oceans.
Just piling up slowly over time.
Exactly. And the immense pressure from the Earth compresses that sediment into solid rock. As the environment changes, the type of sediment changes.
Yeah.
And that creates these distinct, visible bands or strata.
So the boundaries between an era or an epoch, they aren't just arbitrary dates we picked. It's not like the boundary between December 31st and January 1st on our calendar.
Right. Nature didn't just print a new calendar page.
In geology, these boundaries are massive, unmistakable physical lines in the stone.
Yeah, they mark genuine, planet-wide physical changes. Like for a new geological time interval to be formally recognized, there has to be a distinct signature preserved in those rock layers.
And it has to be everywhere, right?
Exactly. It must be clear and global enough that a geologist digging in, Australia, and another one digging in Canada can both point to the exact same anomaly.
Wow. Okay, so what kind of anomalies are we talking about?
Well, we are talking about things like the sudden rise or fall of huge groups of life, mass extinctions, dramatic shifts in the Earth's climate, or massive changes to the composition of the atmosphere.
Which brings us to the geological folder we currently occupy, because officially, according to the current geological calendar, we live in an epoch called the Holocene.
Right. And the Holocene began nearly 12,000 years ago, just right at the end of the last ice age when massive glaciers finally retreated.
And the sources made a really interesting point here. When geologists look at the rock and ice core layers from the Holocene, the defining characteristic they see is just incredible stability.
Yes, it has been this remarkably warm, quiet, stable stretch of planetary time.
And the significance of that stability for you, listening right now, it honestly cannot be overstated. That quiet stretch of 12,000 years is literally the cozy cradle in which all of human civilization has flourished.
It really is. I mean, it's essentially been the Goldilocks zone for humanity.
Right, because every farm, every city, every written word, every empire that rose and fell, all of it only happened because the Holocene provided a stable climate window.
The predictable seasons allowed us to invent agriculture, and that allowed for static populations, which, eventually allowed for the modern world.
But, and here's the massive pivot, if the Holocene is defined by that beautiful, quiet stability, the whole proposal of the Anthropocene argues that human activity has violently ended that quiet period.
Right. The argument is that we have pushed the Earth into a brand new, fundamentally different chapter.
But I want to dig into the mechanism of this. Because if geological boundaries require a permanent physical marker in the rock, like the iridium layer left by the asteroid that wiped out the dinosaurs, what on earth are humans laying down today that will survive the shifting tectonic plates?
That's the big question.
Like, are future geologists going to find fossilized smartphones millions of years in the future?
Well, I mean, probably not an intact smartphone,
Yeah.
but it really all comes down to permanence. What is going to become the rocks of tomorrow?
Okay, so let's methodically walk through the evidence detailed in our source material, starting with something we use every day, plastics.
Right, plastics. We manufacture plastic on such a colossal scale, and as we all know, it takes so incredibly long to degrade. So it's now spread across literally every corner of the planet.
Yeah, the sources mentioned it's not just sitting in landfills anymore. Microplastics have made their way all the way down into deep ocean sediments.
And that's crucial, because when those ocean sediments slowly pile up and eventually get subjected to the immense heat and pressure of the Earth's crust over millions of years, they bake into sedimentary rocks.
Because the plastic becomes part of the rock.
Exactly. The synthetic polymers of our plastic trash will get permanently locked into that rock matrix. They won't look like a perfectly preserved water bottle, but they will form a distinct, carbon-heavy chemical band that has just never existed in nature before.
Wow. And some geologists call these technofossils, right?
Yes, technofossils. It's a weird synthetic band of rock just wrapping around the entire globe.
That is wild to picture. And then the sources detail the impact of concrete, which, if you think about it, is essentially just an artificial rock that we invented.
Yeah, that's exactly what it is. And we have poured such a staggering volume of concrete that it basically coats the planet's surface in a way nothing in nature ever naturally has.
So it's this dense footprint that will absolutely leave a massive scar in the geological record.
Absolutely. And it's not just the solid stuff on the ground. We're also leaving permanent markers in the atmosphere and the oceans.
Okay, how does that work? Like, how does air become rock?
Well, think about the slow carbon cycle. Normally, the Earth regulates its temperature over millions of years. Carbon gets locked in rocks. It's slowly released by volcanoes into the atmosphere, absorbed by rain, washed into the oceans, and eventually settles back into the rocks.
A very slow, balanced loop.
Exactly. But humans have dug up hundreds of millions of years worth of stored carbon like coal and oil, and we've burned it in a matter of just a few decades.
Which drastically alters the atmospheric chemistry really fast.
Right. And by changing the air so quickly, we are changing the ocean's chemistry. As the oceans absorb all that excess carbon, they become more acidic.
And the sources say that acidification changes how certain microscopic sea creatures form their shells?
Yes, it fundamentally alters their biology. So when those trillions of creatures die and fall to the ocean floor, the actual makeup of that sediment is changed. Future geologists will see a sudden, really sharp shift in the chemical composition of the limestone and chalk that's forming right now.
That is just, wow. So we are changing the air, which changes the water, which changes the mud, which eventually becomes the stone. It's like this domino effect of permanence.
It really is. Everything is connected.
But, okay. One of the most memorable details from the source material, for me anyway, is the fingerprint of agriculture. I was just totally fascinated by how industrial farming is going to look to a paleontologist like 2 million years from now.
Oh, the fossil record of the present day is going to
Uh-huh.
look incredibly strange to them. I
Uh,
mean, future paleontologists will find this overwhelming, globally distributed presence of billions of domestic animals.
Specifically cows, pigs, and chickens, right?
Yes,
Yeah.
specifically them. The sheer biomass of domestic animals completely dwarfs all wild mammals and birds today.
The stat that blew my mind was the chickens. We are essentially laying down a global layer of chicken bones.
Yeah, it sounds almost funny, but it's true. Because of the incredible scale of industrial poultry farming, the modern broiler chicken is actually the most numerous bird on the planet. Its bones are going to be absolutely everywhere in the fossil record.
Just a global stratum of chicken bones. That is crazy to think about.
And right alongside those bones, you have the chemical footprint of farming. Our use of artificial fertilizers has been so extensive that we have actually doubled the natural flow of elements like nitrogen and phosphorus through the environment.
Doubled it. Globally.
Yeah, those chemicals run off our fields, they enter the river systems, and they settle into the sediment. So that massive chemical spike will also be permanently locked into the rock.
Okay, I also want to make sure we bring up the 1950s atomic tests. Because of all the evidence in the source material, this seems like the most dramatic piece.
Oh, it is arguably the sharpest marker of all of them. In the mid-20th century, humanity began detonating nuclear weapons above ground.
Right, the atmospheric tests.
Yeah, and those tests sprinkled radioactive isotopes worldwide within a span of just a few short years.
And just to clarify for everyone, an isotope is basically a variant of an element that has extra neutrons, which makes it unstable and radioactive, right?
Yes, exactly. And the key thing for geology is that they decay at a very specific, predictable rate. So they act like a built-in clock in the rock.
Oh, that's incredibly useful for future scientists.
It is. When future geologists examine our layer, they won't just see a gradual shift in chemistry like with the carbon cycle. They will see a razor-sharp global marker of radioactive isotopes like plutonium-239 that just suddenly appear everywhere, all at once.
So if we take all of this together, the technofossils from plastic, the sheer volume of concrete, the chemical shift from carbon and fertilizers, the global layer of chicken bones, and the radioactive fallout, I mean, these create exactly the kind of clear, global, lasting signals that geologists use to mark the boundaries of deep time.
They really do. The evidence points to a massive planetary transition. The end of an epoch is almost always marked by something sudden and dramatic in the rock.
Like we mentioned earlier, the asteroid impact that ended the age of the dinosaurs.
Right. Except in this case, the geological force reshaping the biosphere isn't coming from space.
The cause is us, which, and this is where the story gets really interesting, leads us to a fascinating scientific plot twist.
Yeah, the plot twist.
Because with all this staggering planet-wide evidence, you would naturally assume that declaring the Anthropocene an official epoch is just a settled fact. You'd think the textbooks are already being updated.
You would think so, yes.
But science requires rigorous honesty, and as of right now, based on the sources we're looking at, the Anthropocene is actually not an officially recognized division of geological time.
No, it is not. The international scientific bodies, the specific committees of stratigraphers who formally govern the geological timescale, they actually recently declined to ratify the Anthropocene as a new epoch.
Wait, really? So they voted it down. I think this is where the scientific community is actually fractured right now, which is just fascinating. Because it's crucial to understand that the formal rejection by these committees is absolutely not a group of scientists saying humans aren't having an impact.
Oh, no, not at all. Let's be very clear about that. The broad scientific reality of human transformation is completely undisputed by these groups. No one is denying what's happening to the environment.
Okay, so if the evidence is literally written in concrete and radiation, why isn't it official yet? What is the debate actually about?
The debate entirely centers on the nuance of how geology actually works as a bureaucratic and scientific discipline. Administrative rules, basically. Exactly. To create an official epoch, you cannot just point to a general trend of environmental change and say, look, things are different. The rules of stratigraphy require strict, very rigid thresholds. They need a precise, globally agreed-upon starting marker in the rock.
Oh, I read about this. In geology, this is affectionately called a golden spike, right?
Yes, a golden spike. Or, if you want the official term, a global boundary stratotype section and point.
I think we'll stick with Golden Spike, but that is a literal specific location on Earth, isn't it? Like maybe a specific cliff face in Italy or a lake bed in Canada.
Right, it's a real place where geologists can point to one exact millimeter of rock and say, right here, at this specific line, the epoch officially began.
So that level of precision has to be the heart of the problem here.
It is. Finding a single synchronous marker for human impact is incredibly difficult. Why? Because human history is terribly messy and asynchronous.
Right, we didn't all do the same things at the exact same time.
Exactly. For example, some scientists argue the Anthropocene should start with the agricultural revolution thousands of years ago, because, that's when we started clearing forests en masse and raising methane-producing livestock.
But the agricultural revolution didn't happen everywhere at once. It took thousands of years to spread across the globe, so it doesn't leave a clean, single line in the global rock record.
Precisely. Other scientists argue it should start with the Industrial Revolution in the 1800s when we started burning coal. But again, industrialization was gradual. It was regional.
So what did the group pushing for the Anthropocene propose?
They argued that the best golden spike is actually the radioactive fallout from those 1950s atomic tests we talked about. Because it is sudden, it is global, and it leaves a permanent chemical line everywhere simultaneously.
Okay, but if you use the 1950s as the official starting line for the Anthropocene, you're essentially telling the historical record that all the massive human impacts before 1950 don't count as part of the human epoch.
And that is the exact tension that caused it to be voted down.
It ignores thousands of years of deforestation, the extinction of countless species, the entire Industrial Revolution.
Right. The stratigraphers voting against it were making a careful, highly technical judgment. They felt that pinning the entire human transformation of Earth to a single date in the 1950s was just too restrictive. It didn't accurately reflect the long, really complex history of our interaction with the planet.
So they were basically arguing over administrative boundary lines, not denying the reality of what we are doing to the Earth.
Yes, exactly.
The analogy from the source material that perfectly summarizes this administrative tension is thinking about a house renovation.
Oh, the house analogy is great.
Yeah. So imagine a new family moves into an old house and immediately starts knocking down walls, tearing up the floorboards, painting everything neon green. Everyone in the neighborhood can clearly see the sledgehammers. The physical transformation of the house is totally obvious and undeniable.
Meanwhile, down at the city council.
Right. Down at the city council, the bureaucrats are locked in this heated, endless debate over the exact millisecond. The new residency officially began for tax purposes. Did it start when they signed the mortgage, when they moved the first couch in, or when they knocked down the first wall?
And the paperwork of geology just requires a level of synchronous precision that makes the Anthropocene really difficult to formalize right now. But it's worth noting that even the scientists who oppose the formal designation still use the word Anthropocene in their daily work.
So it's still a highly relevant concept.
Oh, very much so. They see it as a profoundly legitimate way to describe this age of human influence. They just don't think it fits neatly into the rigid filing cabinet of a formal geological epoch based on the current traditional rules.
So the honest summary for you listening right now is this. The human impact on the Earth is real, it is actively being written in the stones, and it is widely accepted by the scientific community. The rigorous debate over how to categorize it is simply a reflection of scientists taking their discipline really seriously.
Yeah, that's exactly the right way to frame it.
Which brings us to the final piece of our deep dive today. Because whether or not the Anthropocene ever gets a formal golden spike on a chart somewhere, the deeper reality of this concept fundamentally changes our understanding of ourselves.
It really does. We have to weigh human actions against the entirety of Earth's history. For almost all of that 4.5 billion year timeline, the great forces shaping the planet were entirely blind and unthinking.
Right. A dinosaur couldn't stop a wandering ice age.
No. Early sea life couldn't halt the drifting of tectonic plates. Life just had to adapt to whatever the Earth blindly decided to do.
But the source material highlights this awe-inspiring and honestly slightly terrifying fact. If you compress Earth's entire history into a single 24-hour clock, human beings show up in just the last few seconds before midnight.
It's a tiny blip.
A tiny blip. Yet in that fraction of time, our mining, our construction, and our agriculture now move more rock and soil around the surface of the Earth than all the natural rivers combined.
Think about that. A single species has joined the ranks of ice ages and tectonic plates. We have literally become a force of nature.
And understanding the scale isn't just about, memorizing facts to sound informed at a dinner party. The argument for science itself is that this knowledge allows us to see our own massive effects clearly.
And to weigh them honestly. With that staggering planetary level power comes an incredible responsibility.
Absolutely. The Anthropocene is essentially a mirror held up to our species. It's a geological record being written right now, today, about what we chose to do with our brief moment of enormous power.
We are the very first species in the history of the entire planet to actually be aware that we are leaving a layer in the rock,
We have the unique capability to study our own impact in real time.
which is an incredible privilege but a huge burden.
It is. Which leaves us with a final thought to mull over as you go about your day. Think back to that massive silent librarian we talked about at the very beginning of the deep dive, methodically recording everything in the Earth's stone diary.
Still writing, even right now.
Millions of years from now, if some future geologists, whatever they might look like, if they examine the rock layer we are leaving behind in this exact moment, what story will it tell? Will they see a chaotic, polluted layer of plastic and radiation that eventually stabilized and thinned out because we learned to balance our tremendous power? Or will the Anthropocene just be a thin, abrupt, devastating boundary line marking our sudden, dramatic end?
It's quite a question to leave people with.
It is. The geological record is still being written, and thankfully, for now, the pen is still in our hands.